Hey, Dirk here. Welcome to the dungeon. So, I got an awesome project that I just finished up last night. Mini, not the mini, the micro. The micro solid state Tesla coil. Obviously, I got to put this into a box still. I do have a few ideas for a box. Somewhere here. Here we go. Well, this is probably. This will probably go into the mini. Or the mini, yeah, that's probably going to the mini. The mini will probably go into this one right here. This was basically an old, basically it was like a cable splitter with multiple outlets. Or I think this was for the old satellite. Anyway, I think everything around here is metal. Most of the insides are metal. This is basically, I want to put it in here for shielding from RF, at least for the mini. The micro will probably get something smaller for shielding. These are based off of, get this out of the way, I was actually playing with a fluorescent tube. Let's see here. So this is the mini. These are ski boards. So all the credit goes to Steve Ward. And this is the one that I built, which is the micro. I actually used a different non-inverting, get that right? Yep, non-inverting gate chip. I used the UCC type, which is the UCC 37322 from the mini one. I put it on here. The added bonus of using that one as opposed to this one is you're able to use the enable pin on pin 3. I'll go back to this one. Yeah, pin 3 on here. Inside is a Schmidt trigger. So, you can hook up an interrupter, which basically what this part of the circuit is. Yeah. Or you can do audio modulation, and that's going to come later. Sparky Project actually drew that out and put it on Google Plus yesterday. And what I'll do is I'll take this, put this on PhotoSuite, slightly edit it, put the right chip in there because the UCC needs a large decoupling capacitor, a 1 microfarad decoupling capacitor, yeah, on there, on the circuit. I'll go back to the other one here. Let's see here. It's right there. You have to go to the website, you know. My light is washing this out because this is white as well. And then I'll go ahead and add in the interrupter and then the audio modulation circuit as well. So if anybody wants to build that, you know, the micro version right here, they can go ahead and do that. And this is actually really good. A circuit, I'm quite impressed. Just a single MOSFET right here. This is basically a protection capacitor, which obviously works pretty good. I might use this later on for running flybacks and other high frequency transformers, basically, to basically stop any nasty kickbacks coming from the primary, which is right here. What else we got here? There's your gate driving chip. There is a 555 right here that's giving out a little over 200 kilohertz, and what that basically does is that kickstarts the coil. It's basically acting as a switch. It kickstarts it, and then the RF is going to come back on this really long antenna. I'm playing with the antennas, and this seems so far to be a pretty good setup. I still also have to play with the primary on here. Maybe reduce a bit of the turns and see if that improves the output. Anyway, the feedback comes in here from the coil, and then this will basically start to self-oscillate, and the signal that's coming in through the antenna is going to be stronger than what's being produced by the 555. It basically overrides it. But you know, if you're doing anything, you're getting close or far away, or you're pulling arcs or whatnot, the 555 is there to help kickstart it, you know, back into oscillation. So yeah, it's basically, you know, self-correcting itself. But the way I have it set up right now, I don't seem to be affecting the coil too much. And I'm also playing with top loads. This is the original top load, along with this, to make this, 387 kilohertz. But this actually isn't needed. It actually makes it worse. I also tried it with no top load, just right on top of there. You know, you can basically put whatever you want on top of there to run it. As far as toroids, this actually seems to work better than having no top load. So this is pretty good right here. Little breakout point. And that's basically it. It's really simple. This will be, the mini one will be next here. I'm still waiting on this damn chip right here, which basically what Sparky had told me yesterday is basically a logic IC with 6 Smith triggers inside, and I think you're only utilizing 1. Yeah, and then obviously I got to make a what was that? It was a gate transformer. I forget what the hell it is. You know, using the fucking toroid, something like that. I'll have to experiment with that. So I'm just waiting on those parts. I already have the power supply, which I'm using for this one right now. I already built that 555 for it. Around here somewhere. Maybe I didn't. Okay. Well, anyway, this will be next, and this should be pretty damn awesome. This is pretty kick-ass. So enough rambling or waffling on, as some of you guys like to say there in the UK regions. So let's have a bit of fun. Let's get some of these lights out here. I was playing with this last night for quite a while. Okay, it's looking pretty good still. I might have to turn off all of the lighting. So what we'll do is we'll ramp this up. I got it running on about 30 volts. It drops down to maybe about 25, 26. Takes when I'm not drawing arcs, it's actually pulling about 4 or 5 amps, and when I am, it's actually dropping that, but it's also dropping the voltage. Yeah. More fine tuning is required. But I got this transformer back here running through the variac so I can control the input and whatnot to lower it, raise it up, you know, all that good shit. So, as you can see, that neon comes directly on, fluorescent tube. Let's see here. This does come on too, but I don't know. I think I kind of busted this a bit, so it's not working as good as it should anymore. And we can start something here. So there's can't see that, but there's a tiny little arc up there. But you can kind of see it on the camera. Kick ass. Alright, let's give it some more juice. And you can see that. Full marks. It's not bad. I don't seem to be affecting the coil too much anymore. You have to play around with your antenna so you get it about just right. And I'm pretty comfortable with having my antenna there. I actually made that antenna longer. So, yeah. Pretty good. Turn that off. And we'll get the other light off here. I have my computer on back here, so that should be enough light for me to see what I'm doing. And it doesn't actually really affect the computer or anything anyway. Obviously the RF isn't going out that far, at least not on these micro ones. Right. And we'll just use the fluorescent tube as lighting. How convenient. You guys can see that. Go ahead and kick this up all the way. The bulb actually gets pretty hot. There you go. see. I'm not quite sure how. Alright, we're already at 10 minutes here. Let's see if we can find one more thing. Machine Man wanted me to try this. So Machine Man, if you're watching, let's see if this works, buddy. We'll do a quick experiment to see if this lights up. I don't know. I'm not really seeing too much. You gotta probably heat that up to excite the gases a little bit. That, or I try to stand it up, but I don't know if that's gonna. I don't think that's gonna stay. Yeah, it's not gonna stay. Sorry. Yeah. There you go. Mini solid, the micro solid state. That's what you're calling it mini, but it's not mini. Yeah. So, hope you guys enjoyed, and stay tuned for the mini one coming up. So, cheers.